The National Electrical Code does not contain a specific requirement mandating the placement location for arc flash hazard analysis labels. The Occupational Safety and Health Administration has provided guidance regarding arc flash hazard analysis labels, but similarly, it does not specify a particular location for their placement. OSHA's guidance indicates that these labels should be prominently displayed at the entry point to the restricted approach boundary, as outlined in 29 CFR 1910.269 SHV. NFPA 70E, which is the standard for electrical safety in the workplace, suggests that arc flash hazard analysis labels be positioned on the exterior of electrical equipment. Specifically, Section 130.4 states that arc flash warning labels must be located in a manner that allows them to be seen by electrical workers before they enter the limited approach boundary. Square D, for example, typically places arc flash hazard analysis labels on the inside of panel doors. This is often done to mitigate the risk of tampering and to protect the labels from exposure to various environmental conditions. However, it is important to note that NFPA 70 advises that labels be placed on the outside of the equipment to ensure optimal visibility for personnel. To address the concerns raised by the state inspector, it is recommended to provide supplementary arc flash hazard analysis labels that can be securely affixed to the outside of the panel doors. These additional labels should accurately reflect the information provided on the interior labels and should be firmly attached to prevent any potential tampering or removal. There are additional considerations that should be taken into account to make sure that the appropriate precautions have been followed to ensure that safety is met. Firstly, the placement of arc flash hazard analysis labels should be reassessed if the equipment is relocated or undergoes any modifications. Secondly, it is vital to ensure that the labels remain legible and easily visible, even when operating in low light conditions. Thirdly, it is imperative that personnel receive comprehensive training on the location of arc flash hazard analysis labels and their significance in promoting workplace safety. Arc flash is a dangerous electrical explosion that occurs when a flashover of electric current leaves its intended path and travels through the air from one conductor to another, or to ground. This can happen when there is damaged or degraded insulation, dust condensation, corrosion, or accidental contact with tools or other equipment. Arc flashes can cause severe burns, blindness, hearing loss, and even death. They can also damage equipment and cause fires. Arc flash hazard analysis is a study that determines the potential arc flash hazards in a facility. The analysis calculates the incident energy, arc flash boundary, and required personal protective equipment for each piece of equipment. Incident energy is the amount of energy that a worker could be exposed to during an arc flash event, measured in calories per centimeter squared. The arc flash boundary is the distance from the arc flash source where the incident energy is equal to 1.2 calories per centimeter squared, which is the onset of a second-degree burn. Personal protective equipment, also known as PPE, is clothing and equipment worn to protect workers from arc flash hazards. The type of PPE required depends on the incident energy level. The National Fire Protection Association, also known as NFPA 70E standard, provides guidance on how to perform an arc flash hazard analysis and select the appropriate PPE. The hierarchy of risk control methods is a systematic approach to identifying and mitigating hazards. It involves implementing control measures in a specific order, starting with the most effective and progressing to the least effective. The hierarchy of risk control methods is as follows. Firstly, elimination, which involves removing the hazard altogether. This is the most effective control measure, but it is not always possible. Secondly, substitution, which involves replacing the hazard with a less hazardous alternative. For example, using a low voltage system or using non-conductive tools. Thirdly, engineering controls, which involve making physical changes to the workplace to reduce the hazard. For example, installing arc flash barriers or using remote racking systems. Fourthly, administrative controls, which involve implementing procedures or policies to reduce the hazard. For example, developing safe work practices, providing training, and using warning signs. Fifthly, personal protective equipment, which involves providing workers with clothing and equipment to protect them from the hazard. PPE is the least effective control measure, but it is often necessary as a last line of defense. There are several types of personal protective equipment that can be used to protect workers from arc flash hazards. These include arc-rated clothing, which is clothing that is designed to protect workers from the heat of an arc flash. Arc-rated face shields protect the face and eyes from the arc flash. Arc-rated gloves protect the hands from the arc flash. Arc-rated footwear protects the feet from the arc flash. Hearing protection protects the ears from the noise of the arc flash. When working on or near electrical equipment, it is important to follow safe work practices to prevent arc flashes. These safe work practices include energizing equipment before working on it. If it is not possible to energize the equipment, then use appropriate PPE. Maintain a safe distance from energized equipment and use insulated tools. Never work alone and be aware of your surroundings. Arc flash labels are required by the National Electrical Code to be placed on electrical equipment that may be subject to an arc flash hazard. The labels must include the following information: the nominal voltage of the equipment, the arc flash boundary, the incident energy at the working distance, and the required personal protective equipment. The labels must be legible and visible to workers before they approach the equipment. The purpose of arc flash labels is to warn workers of the potential arc flash hazard and to provide them with information on how to protect themselves. It is important to understand the information on the labels and to follow safe work practices when working on or near electrical equipment. Electrical safety training is essential for all workers who work on or near electrical equipment. The training should cover the hazards of electricity, safe work practices, and the use of personal protective equipment. Workers should also be trained on how to respond to an arc flash event. Regular electrical safety training can help to prevent arc flashes and protect workers from injury or death. The information provided on arc flash labels is intended to protect workers from potential hazard. It is crucial to understand the meaning of each element on the label and to follow the recommended safety precautions. The nominal voltage indicates the voltage level of the electrical equipment. This information helps workers understand the potential severity of an arc flash event. The arc flash boundary is the distance from the equipment where the incident energy is equal to 1.2 calories per centimeter squared, which is the onset of a second-degree burn. Workers should never enter the arc flash boundary without wearing appropriate PPE. The incident energy is the amount of energy that a worker could be exposed to during an arc flash event. This information helps workers select the appropriate PPE for the task. The required personal protective equipment is the clothing and equipment that workers must wear to protect themselves from the arc flash hazard. This may include arc-rated clothing, face shields, gloves, and footwear. In addition to the information on the arc flash label, workers should also be aware of the following safety precautions. Always to energize equipment before working on it whenever possible. If it is not possible to de-energize the equipment, then use appropriate PPE. Maintain a safe distance from energized equipment and use insulated tools. Never work alone and be aware of your surroundings. By following these safety precautions, workers can significantly reduce their risk of injury or death from an arc flash event. Arc flash is a serious hazard that can cause severe injuries or death. By understanding the hazards of arc flash and following safe work practices, workers can protect themselves from this danger. The National Electrical Code, the NEC, provides comprehensive guidelines for electrical installations to ensure safety. It covers various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect the latest advancements in technology and safety practices. Compliance with the NEC is essential for protecting people and property from electrical hazards. Some key areas covered by the NEC include wiring methods. The NEC specifies the types of wiring methods that are permitted for different applications. It also provides requirements for the installation of wiring, such as the spacing between conductors and the support of cables. Overcurrent protection, which is intended to protect electrical systems from overloads and short circuits. The NEC specifies the types of overcurrent protection devices that are required for different applications, such as fuses and circuit breakers. Grounding is intended to provide a path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC specifies the requirements for grounding electrical systems, such as the size of the grounding conductor and the location of the grounding electrode. Equipment installation guidelines are there to ensure that electrical equipment is installed safely and correctly. The NEC specifies the requirements for the installation of different types of equipment, such as transformers, switchboards, and panel boards. The Occupational Safety and Health Administration, also known as OSHA, is responsible for ensuring the safety and health of workers in the United States. OSHA has established regulations that address a wide range of workplace hazards, including electrical hazards. OSHA's electrical safety regulations are based on the National Electrical Code and other consensus standards. Compliance with OSHA's electrical safety regulations is mandatory for all employers in the United States. OSHA's electrical safety regulations cover a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and personal protective equipment. OSHA also requires employers to provide electrical safety training to their employees. The National Fire Protection Association, NFPA, is a non-profit organization that develops and publishes consensus standards for fire and electrical safety. NFPA standards are widely used in the United States and around the world. NFPA 70E, Standard for Electrical Safety in the Workplace, provides guidance on how to protect workers from electrical hazards, including arc flash and electric shock. NFPA 70E covers a wide range of topics, including electrical safety-related work practices, safety requirements for special equipment, and personal protective equipment. NFPA 70E is updated every 3 years to reflect the latest advancements in technology and safety practices. Compliance with NFPA 70E is not mandatory, but it is widely recognized as a best practice for electrical safety. Arc flash hazard analysis is a critical component of electrical safety programs. It involves assessing the potential arc flash hazards in the facility and determining the appropriate safety measures to protect workers. The arc flash hazard analysis should be performed by a qualified electrical engineer or other qualified person. The results of the arc flash hazard analysis should be documented and used to develop safe work practices and select appropriate personal protective equipment. The arc flash hazard analysis typically includes the following steps. Firstly, data collection, which involves gathering information about the electrical system, such as the voltage, current, and fault clearing time. Secondly, modeling, which involves creating a computer model of the electrical system to simulate arc flash events. Thirdly, calculations, which involves using the computer model to calculate the incident energy, arc flash boundary, and required personal protective equipment at various locations in the electrical system. Fourthly, documentation, which involves documenting the results of the arc flash hazard analysis in a report. Arc flash risk assessment is the process of evaluating the likelihood and severity of an arc flash event. The arc flash risk assessment should be performed by a qualified electrical engineer or other qualified person. The results of the arc flash risk assessment should be used to prioritize safety improvements and to develop safe work practices. The arc flash risk assessment typically includes the following steps. Firstly, hazard identification, which involves identifying potential arc flash hazards in the workplace. Secondly, risk analysis, which involves evaluating the likelihood and severity of each arc flash hazard. Thirdly, risk evaluation, which involves determining whether the risk of each arc flash hazard is acceptable. Engineering controls are physical changes to the workplace that reduce the risk of arc flash events. Engineering controls are the most effective way to reduce the risk of arc flash events, but they can also be the most expensive. Some common engineering controls include arc resistant switchgear, remote racking systems, and current limiting devices. Administrative controls are policies and procedures that reduce the risk of arc flash events. Administrative controls are less effective than engineering controls, but they can be a cost-effective way to reduce the risk of arc flash events. Some common administrative controls include safe work practices, electrical safety training, and warning signs. Personal protective equipment, which is known as PPE, is clothing and equipment that protects workers from arc flash hazards. PPE is the last line of defense against arc flash hazards. It should only be used when engineering and administrative controls are not feasible or do not provide adequate protection. Some common types of PPE include arc-rated clothing, face shields, gloves, and footwear. Electrical safety training is essential for all workers who work on or near electrical equipment. The training should cover the hazards of electricity, safe work practices, and the use of personal protective equipment. Workers should also be trained on how to respond to an arc flash event. Regular electrical safety training can help to prevent arc flash events and protect workers from injury or death. Safe work practices are procedures that workers should follow to reduce the risk of arc flash events. Safe work practices should be developed based on the results of the arc flash hazard analysis and risk assessment. Some common safe work practices include energizing equipment before working on it, using insulated tools, maintaining a safe distance from energized equipment, and wearing appropriate PPE. Electrical safety audits are regular inspections of electrical systems and equipment to identify potential hazards. Electrical safety audits should be performed by a qualified electrical engineer or other qualified person. The results of the electrical safety audit should be used to identify and correct any hazards. Electrical safety audits can help to prevent arc flash events and protect workers from injury or death. Electrical safety programs are comprehensive plans that outline how an organization will protect workers from electrical hazards. Electrical safety programs should include policies and procedures for arc flash hazard analysis, risk assessment, engineering controls, administrative controls, personal protective equipment, electrical safety training, safe work practices, and electrical safety audits. An effective electrical safety program can help to prevent arc flash events and protect workers from injury or death. Specific consideration should be taken into account when choosing where to put up labels. Visibility is a key factor in determining the optimal placement of arc flash labels. The labels should be positioned in a location where they are easily visible to workers before they approach the electrical equipment. The labels should not be obstructed by any objects or equipment. Readability is also key. The labels should be legible and easy to read. The text on the label should be clear and concise. The label should be printed in a font size that is large enough to be easily read from a distance. Environmental conditions also play a role. The labels should be placed in a location where they are protected from environmental conditions such as moisture, dust, and sunlight. Exposure to these conditions can damage the labels and make them difficult to read. Accessibility is also something to think about. The labels should be accessible to workers who need to read them. The labels should not be placed in a location that is difficult to reach or that requires workers to climb or reach over obstacles. Consistency is also important to remember. The label should be placed in a consistent location throughout the facility. This will help workers to quickly and easily find the labels they need. NFPA 70E provides guidance on the placement of arc flash labels. NFPA 70E states that arc flash labels should be located so that they are visible to workers before they enter the limited approach boundary. The limited approach boundary is the distance from the electrical equipment where a person could be exposed to an arc flash hazard. The specific requirements for the placement of arc flash labels may vary depending on the specific electrical equipment and the specific hazards involved. However, the general principles outlined above should be followed to ensure that the labels are effective in protecting workers from arc flash hazards. In summary, arc flash label placement is a critical aspect of electrical safety. By following the guidelines outlined above, you can ensure that arc flash labels are effective in protecting workers from arc flash hazards. These guidelines and regulations are in place to make sure that safety is always prioritized and that accidents are kept to a minimum in the workplace. Make sure to always double-check and triple-check all rules and regulations and that any updates on the code are addressed. The NEC is constantly updated, and it is essential to review any and all changes made to ensure compliance and to stay up to date on new and existing changes. Make sure to consult with a professional if you have any further questions about your unique equipment or if there are any other questions on best practices.